Fellow scientists, it's good to be back. It's your favorite sensei here, Sensei Mohao, and today we are going to be dealing with a past question paper of June 2025, but we'll be focusing on sequences and series. Hope you all are good. Hope you all are having a wonderful week as I am. And yeah, on this lesson, I will be showing you how to answer the most highest difficult questions in sequences and series. Now, here in this question, what is happening? Now, I know it can be a bit confusing because of you are seeing triangles, others are upside down, others are normal triangles, big, small. Now, this is very easy. So now remember now, as you advance in this topic, they are going to give you certain problems. Ne? So it's basically a normal problem, normal series and sequence problem, but they will bring it to you not in the same way that you are used to, like not in the normal way that you are used to of getting problems of sequences and series. So hence why it can be a bit challenging, but the method and everything is the same. So without any further ado, let me just stop talking too much about how you'll be doing it and just simply show you the trick of how you will do this thing. Now let's kick in now. So a question says an equilateral triangle RST with sides of length. So now remember, let's go back to grade 8. An equilateral triangle, what is happening in an equilateral triangle? It means all sides are the same. Ne? That's the first hint. Ne? All sides are the same. So hence I said it's a normal problem, but they don't bring things to you in the normal way that you are used to of getting things. Ne? So we know if this is an equilateral triangle, every side here we have 12p, we have 12p, we have 12p on every single side. RT, we know that RT, basically here we just simply just doing geometry, né? But it's just the same thing. It's just normal grade 9 stuff here. And the RS, né? So we know that they are equals to 12p. Now they say a second triangle. So now remember that the first triangle T1, we know it had 12p as the sides, ne? So the second one, ne, I'm just going to do it like this. So it is a triangle with the sides that have 12p, sides length, ne, with that are 12p. So now the second one, now a second triangle is drawn by joining midpoints of the first triangle. Now remember, let's recap. If we have a midpoint, what happens? Now remember, midpoints cut a particular line into two equal lengths, né? So we have 6p here, we have 6p here, which means we'll be having 6p here, 6p here, so 6p here, and also here. Now get the second triangle. Now, ne? The bigger triangle is RST, and then the second triangle is this one. So I want you to understand something, ne? Now all these triangles, ne, are going to be equilateral triangles, ne? Why am I saying that? It's simply because, ne, the sides are cut through the midpoint again, which means now it will be 6 6 6. Here it will be also 6, and also the side, and also the side. So you can see now basically for us to go to the third triangle, we just divide 6 by 2. Basically it will be 6p, the length of the sides. Ne? The third triangle will be 3p, the length of the sides. Ne? Basically. Ne? Now, hence I'm saying that now this is a normal equation, ne, that we are used to, but now they are not bringing it in the way that we are used to. The way of getting things, they are not doing that, ne? Which means they are not spoon feeding you. They are just simply just like giving something to you in a very different and common way. So most students, when they found this type of questions, maybe let's say in sequences and series, they're giving you a 2D or a 3D diagram, they always panic and they always skip the question. So hence I'm here to help you so that you won't run away, you won't back down from a challenge. Ne? So it's just the same thing. Ne? It's the same thing, same triangle, but now they are giving things to you in parables and in 2D shapes. Ne? So don't get confused. It's the same thing that we are used to of doing sequences and series. So now you can see now by guessing on the sides from triangle 1, triangle 2, triangle 3, what kind of a sequence is this? Is it a geometric, arithmetic, quadratic? Very good. It's a geometric pattern. Again, it's a geometric sequence or geometric pattern. Why? Because of the ratio, it's dividing by 2, which means for us to go to the next triangle sides of each length of each side, we will divide this by 2. It's 12 divided by 2, it's 6. 6 divided by 2 is 3. Then 3 divided by 2, it will be equal to 3 over 2. So basically we just divide to get the next thing. Ne? So each triangle is therefore drawn by joining the midpoint of previous triangle as shown, and it continues. Ne? So which means this now means that it continues, it's infinite now. Ne? It's infinite, it continues. We don't have a particular end point of this series or pattern, hence why it's an infinite pattern. Ne? So now they say, now first question, write down the term of p. Okay, in terms of p, the length of each side in the in the second triangle. Ne? Very good. It's 6p. Why 6p? Because of now this triangles, now the second triangle will have, it's this one, it will have now the from the midpoint, it will now make this and this and this an equilateral, which means it will now make this 6 and 6 and 6. Basically it's just something like that. Ne? So it's just 6p, the length of each side. Remember, it's an equilateral triangle, so you know it's 6p. Number 1, we know it's 6p. Ne? So now calculate in terms of p the perpendicular height of RST. Now here is the tricky part. Now ne? When it comes to the perpendicular height, let me find a straight line. Now when it comes to the perpendicular height, remember, let me just do it black. The perpendicular height, it's a line that cuts evenly in the middle of this triangles. Ne? So now if it cuts evenly in the middle of those triangles, which means now these triangles now are going to be now right angle triangle. Now, remember, if we have perpendicular height, or if we want the perpendicular height of this, which means we will cut this from the midpoint here to the midpoint here, which will now make this, and yet it was basically like that, 6p, and yet, and this one will be 12, and yet, and then this one we are looking for this side here. So remember now, because of the perpendicular height, we will now make this now a right angled triangle. Let me shade it in a different color. Let me just choose orange. Let me just increase the brush size. So now here we know that if we are looking for the perpendicular height, it will now make this now a right angled triangle. Let me just erase on those parts. So now it will now make this a right angled triangle. So now remember, now let's go back to grade 10. Right angle triangle, they always have this angle. Remember this. Right angle triangle always have this angles. It's either it's 30 or 60. It's always that case when it comes to the right angle triangle. And yeah, it was always 30 or 60. Remember, whenever we were doing the special angles, we know we would have 30 here and 60 here, and yeah, remember that. And then yes, I know we have others, 45 and 45, but if we know, remember, if we have angles of 45 and 45 here, which means now this is now basically an isosceles right angle. But right now here, we don't know the side of this perpendicular height. We want the size of the perpendicular height. So now, excuse me. So now, which means that we can do it in both ways now. We can do it in both ways. And yeah. So now, we have two things now. It's all up to you. Which method do you choose? It's all up to you. But I would choose this one of using theorem of Pythagoras. Remember, we have this particular angle. We have this adjacent side. We want the opposite side. We have the hypotenuse side. So which means we can use theorem of Pythagoras to find this side. So which means now it will be y squared equals to r squared minus x squared. Remember, if you are still questioning where does this come from, remember grade 12s, it's x squared plus y squared. But now because of we are solving for y squared, then it's easy for us to take this to the other side, and then we make y the subject of the formula. So now let's continue. 12p squared minus 6p squared. So now we know that here now we will have now 144p. Let me just erase on the sides here. We'll have 144p. Let me just hide this, let me just hide. Okay, I'll just do it again. I just wanted some space here because of it's all messy. So remember, it's here we have y squared equals to remember it was 12p squared here on the side, and here it was 6p, so minus 6p all squared. It's going to give us here, remember here it's 12p times 12p, which is multiplying this ones will be 144, then p to the power 2. Remember that law of exponent. Then 6 times 6, it's 36p to the power 2 minus 36p squared. So now here, now 144 minus 36, let's count in the calculator very fast. 44 minus 36, the answer will be equals to 108. 108p squared. So if we find now the square root of this 108 square root, it will be 6 root 3 and p. Remember the reason why it's p, because of it's under a square root, so we know that this will also be basically to the power 1 because of the square root. So now basically this is the answer. Remember, what did we do? We are looking for the perpendicular height, which is this height here. We are looking for this height here. And now we know that since we have a perpendicular height, it makes now this now an angle of 90 degrees here, which now makes now this angle a right angle triangle. So hence why we use theorem of Pythagoras. I know maybe most of y'all may have chosen to make probably using the trig ratios. Let's just try it. Let's just try using trig ratios. So now let's just say here it's 60 and here it's 30. So now, which means now it's going to be like this. So remember now here, when we are using 60, this is the opposite side. And get? So since now this is the opposite side, it's going to be sine 60 is equals to now sine 60 is equals to opposite, which is the side that we are looking for. Let's just say h, and over 12p. So definitely we just say 12p multiplied by sine 60 is 12 multiplied by sine 60. Sine 60, remember, is equals to root 3 over 2. Root 3 over 2. So it's root 3 over 2 multiplied by 12 p. We know that we are going to just be dealing with the numbers, so it's going to be 6 over root 3 then p. Easy as that. Remember, whether you used sine 30 or sine 60, it will just take you back to the same answer, which is this one. Let's just test using sine 30 how would have been the answer. So now here it's going to be, now this will be now the adjacent side, so which means it's cos 30, and we know that cos 30 is equals to sine 60 basically, hence why it's just the same. So now let's continue without any further ado. Now they want the sum of terms, and remember now when we were reading here, it says it continues indefinitely, so which means now it is infinite. So basically we don't know the last term of this particular pattern. We don't know the last term of this pattern because of its sum of infinite terms. So now they are saying to us now that the sum of all areas will not exceed 48 root 3 and p squared. So now this now basically means that now we have term number 1, but now we are going to be using, since we're about the sum of areas, so which means now we are going to be using now the areas of these triangles as the terms in the sequence. I hope you got that. So it's half base times perpendicular height. Remember the formula to find an area. So now, which means now that it's half base. Now let's focus firstly on the bigger triangle now. I'm just going to shade red here so you can see everything that I'm talking about here. So it's half base, which is 6. Okay, so it's 6 p multiplied by the perpendicular height, which height? This height 6 root 3 that we found, 6 root 3 p, which means now this it's the first step basically, and now the second step. Now I want to remember this. Remember now these triangles are all equilateral triangles, which means now each and every the second triangle it's half of that, that triangle half of that, just like that and so forth. So which means now if now the second triangle the base is equal to, oh sorry, here I said half base, sorry, I already did the half base myself and I didn't correct it there. It's half base, which is 6 basically here. It's 6 times 6 root 3. So for the second one it's the half base. Remember, let me erase here again. So remember it's this triangle, this one that is standing upside down. We know that the base here is 6, the perpendicular height of this triangle, it equals to half of this full one of the bigger triangle basically. So which means now it's half base, which is half of 6p multiplied by 6 root 3 p over 2 basically. Why am I saying this? It's because of now we know that these triangles are equilateral triangles, so this means that everything it's just divided by 2, divided by 2, divided by 2. It's through root 3 here on the side. Let me just do it correctly here. Simplified. It's 3 root 3 p. So basically, if we want to move to the area of the third triangle, it will be just half of this and half of this. It's half of this thing. So it's half of 6, we know it's 3, and then half of 3 over 2, so it's 3 root 3 over 2p. It's basically like that. So remember, now this is our first term, second term, third term. Remember that. So now let's continue. So now we have this, remember this formula, half of infinite term is a minus 1 minus r. So in other a, we just have to simplify this. It will be let's simplify it first before half base. We know it's here it will be 6p multiplied by 6 root 3p. So let's just do 6 multiplied by 6 root 3. 6 multiplied by 6 root of 3, it will be 36 root 3. Yeah? So I'm just going to simplify it. It's 36 root 3 p squared. Why p squared? Because of multiplying p and p, which they have the same basis, we just add the exponents. Let's see the answer. 3 times 3 root 3 is equals to squared. This is 2 here. Now let's do the third one here. So it's 1 over 2. So here is 1 over 2. 1 over 2 of this 3, it's basically 1,5p. It's just 1,5p multiplied by root 3 over 2. Okay. It's 3 over 2 multiplied by 3 root 3 over 2. Let's check in the calculator. It's the full answer. It's just 9 root 3 over 4. 9 root 3 over 4 in p squared. So now, remember now, why are we doing this? Because of firstly, we have to find the ratio of this thing. Ne? Ratio is important. Why do we need to find the ratio? Because we need to know the ratio of this particular terms. Or okay, from first term to second term, we just divide by 4, or we just divide by 2, or we just divide by half, something like that. We just have to do it so that we will know what are we working with. Ne? So now, let's now go to the sum of infinite is equals to a over 1 minus r. Oh, sorry. Let's just find r first. Let's just not rush and let's find r. We know that r is t2, it's 9 root 3 p squared divided by 36 root 3 p squared. We know that this and this, they will definitely cancel out. So 9 root 3 divided by 36 root 3, it will be just 9 over 36, which is just 1 over 4. Like I said earlier on, that because of this here, we know that it's divided by 4. Ne? So our r is 1 over 4. Our r, ne? 1 over 4. So now it's now easy for us to solve this thing, because we know that our r is 1 over 4. Oh, the reason why it's 1 over 4, it's because of, remember, it's the area. So if we have the area, ne? So basically we are multiplying it by 1 over 4, something like that, because of it's a square. And yeah, so we know that it will be 1 over 4. So if it's 1 over 2, square of that, it will be 1 over 4. Ne? But yeah, for now let's just focus on continuing this. So it's a it's 36 root of 3, then p squared, and then 1 minus 1 over 4, and then now that must be equals to this. Ne? So now let's do this. Let's 36 now this will just give us and you remember here it's 36 root 3 over 0.75. Yeah, if you punch in your calculator root 36 root 3, 36 root 3, let's just put the p squares on the side, divided by this minus this is 1, it's 3 over 4. Take your calculator and punch this. 36 root 3 divided by 3 over 4. It will give you 48 root 3, then you know that it's 48 root 3 p squared. Ne? Just like that. So now let's do a simple recap here. Why did we do this whole thing? Remember, first things first, they said we must show the sum of areas, which means now the terms now, the first term, the second term, the third term, and so forth, are now equal to the areas of those angles. Remember, when it comes to the area, we need to know the perpendicular height and the base of the triangle. Yeah? So that's why the first one is the bigger triangle RST, which is it has a base of 12 and then perpendicular height of 6 root 3. So now we know that they told us that they will be joining the midpoints and yet of this triangle, and then draw another smaller triangle inside. So which means now we know that now if now it's like that, we know that the base of this will be equals to half of the bigger one, and yet the base of the smaller one is equals to half of the base of the bigger triangle. Same applies to the perpendicular height. Okay? Then from there on, we have to find the area of the first, second, and third triangle, and then we have to find the ratio. Remember the ratio, it's T2 divided by T1. So which means we just say 9 root 3 divided by 36 root 3, then p squared, and then it gave us 1 over 4. Okay. Then from there on, since now here they're saying we must show that the sum of these terms, they will not exceed 48 root 3 p squared, which means now we must, because of now it's an infinite term, we have to just use this sum of infinite terms. Then we know A, it's the first triangle area, then 1 minus R, which is the 1 minus the ratio. Then punch that in the calculator, it gives us 48 root 3, which is the same answer that we were proving for. Again, thank you very much for watching this video till the end. Make sure you like, you subscribe, you share this video as much as you can to your friends, to your cousins, to your classmates, and hope you enjoy the rest of your day. From me, your favorite sensei, bye bye, peace out, and I hope you all enjoy. Stay tuned next week for another video lesson where we will be dealing with challenging questions in helping you pass your matric with distinctions.